Rahman Rahim. Let's look at this problem. In a biological system, we have two different dominant microorganisms. Organism 1 has a maximum growth rate of 1 per day, substrate affinity of 5 milligram per liter. This is for organism 1. So let's just put the reactor. Let's see, this is the reactor, and wastewater is coming from this side, and there is an organism. Let's say this is 1 and organism 2, and of course at the end of the reaction it will go to the clarifier. So organism 1 has a maximum growth rate of 1 per day and substrate affinity of 5 milligram per liter. Organism 2 has a maximum growth rate of 0.5 per day. This is wrong. And substrate affinity of 1 milligram per liter. The problem is which organism will be dominant at a substrate concentration of 50 milligram per liter, and which one of them will be dominant at 0.1 milligram per liter. Remember, 0.1 milligram, this is very low amount of food, and this is it might be a huge amount of food. So which one of them will be dominant at high concentration of substrate of 50 milligram per liter, and which one of them will be dominant at 0.1 milligram per liter? Let's look at, just solve this one. A, let's see the dominant organism at 15 milligram per liter, and that is S, substrate S. If you put the equation for that, let's put the equation for the monod for organism 1, mu. Remember, what was the mu max for organism 1? 1 per day. Okay, so this is 1 per day, that's mu max. Remember the equation? Let me just put the equation. Mu is equal mu max substrate over, remember, Ks plus S. Okay, so mu max is 1 per day, and then S, the substrate that the food is 15 per day, 15 milligram per liter, sorry, over Ks. He gave you the substrate affinity for organism 1, 5 milligram per liter. So this is 5 milligram per liter plus S. S at the end is the same food that we are putting inside the system. So now the answer would be 15 over 20 times 1, and this would give you 0.75. 0.75, of course, the answer would be, it's a growth, so it's per day. Let's look at organism 2. Mu, and the mu max for organism 2 with the maximum growth rate is 0.5. It's a little bit smaller. Okay, per day, times the substrate that we are having, the food in the system, 15 milligram per liter, over what was the substrate affinity? It's 1 milligram per liter for species, or for organism number 2, plus 15 milligram per liter. So now 15 over 16 times 0.5, and this answer would be 0.47 per day. Now you can see that organism 1 will be dominated at a substrate concentration of 15 milligram per liter. So our conclusion, at substrate 15 milligram per liter, organism 1 will be dominant. Okay, let's look at the other concentration. Now, when we have food at 0.1, When food, let's just, S is 0.1 milligram per liter. Very low amount of food. What will happen? Which one of these organisms will dominate? Let's say organism 1, mu. Of course, mu max will not change. It's the same rate, but now we'll have 0.1. The Ks affinity will not change, plus 0.1. Okay, 0.1 over 5.1 times 1. This would give you 0.02. Let's look at organism 2. Mu, of course, this will not change, 2.5 per day. And this is, the food is similar. And now this is also 1 plus 0.1. And this would give you, okay. So at high concentration of food, organism 1 will dominate over organism 2. At low concentration of food, organism 2, so at substrate 0.1 milligram per liter, organism 2 will be dominant. Okay, so now let's look at the second part of the problem. What is the substrate? Now, we gave them two food concentration, 15 and 0.1. Now, what is the substrate concentration at which both organisms will have the same growth rate? So, which food concentration, or what is the food concentration? What is the substrate concentration? When we just give it to the reactor, both of them will have the same growth rate. So let's look at this. So, well, let's say this is, well, that's not AB. Well, let's see, this is C. When the mu of organism 1 is equal to mu of organism 2, they both have the same growth rate. Of course, the first one, remember that's 1 over day, the mu max. And the food that we're going to be putting in the system is S. So we need to find this S. Plus, Ks does not change. Ks is stuck with the organism, does not change. Plus S equal 0.5 per day S plus the Ks for the second organism, 1 plus 1 plus S. So now you cancel out 1.5, so 5 plus S, so S times 1 plus S, S times 1 plus S, and equal 0.5 S times 5 plus S. Well, here you will have, you'll solve it. So S times 1 is this, yes, S times 1 is S. I don't want to be confusing myself with the 5. So this is the 5. Okay. S times S is 1. But let me just, before we do this, I know I should not use the 5. So S with S is cancelled. Good. So 1 plus S is equal 0.5 times 5 plus 0.5 S. So now you take the other side, it's 0.5 S. You take the other side, it is minus 1 plus 1/2 of 5 is 2.5. So this one is 1.5. So S is equal 1.5 over 0.5. and that would give you 3 milligram per liter of substrate. So at 3 milligram per liter substrate, both organism 1 and organism 2 will be happy. Both organism 1 and 2 will have the same growth rate. At 0.1 milligram per liter of substrate, organism 2 will be dominant. At a substrate concentration of 15 milligram per liter, organism 1 will be dominant. So I guess we could use Monod equation to solve this problem, and hopefully you will understand this. Thank you.